story now.
Tonight we are going to begin to scratch the surface of quadratic equations. You might want to have a little bit of scrap paper handy. We're going to just do a little work. Some of you can do this in your head, but you might want to just jot it down. All right. If I take the equation x squared plus 6 equals 54 and I want to solve that, I'm going to isolate my variable as usual. And when I do that, I get x squared equals 48. Now in the next step, what I really want to do is I want to take the square root of both sides. And this is a very important step because the square root of x squared is x. The square root of 48, positive or negative for radical 3. This is one of the most commonly missed and forgotten symbols in solving a quadratic equation. I don't know where my x went, but you need this. Now, when we're doing Pythagorean theorem problems, it's not applicable because you can't have a negative distance. However, when we are just generally solving a quadratic equation, quadratic equations can have two solutions. What you need to do is remember this positive and negative symbol would apply to a simple quadratic equation like this. So if you have the equation x squared equals 9, it is crucial that you write the positive or negative 3. It is wrong without that. What I'd like you to do is just jot these down quick, pause the video, and solve them. And come back. This shouldn't take you but a couple of minutes maximum. If you're back with me, you see that I have all of the solutions there. And I do have the positive and negative symbol before each of those solutions. So please make sure that you do too. Now that being said, we're going to get lazy for a little while with this. So when we come back to quadratic equations in about a week, you're going to find that we have to again consider that. But since we're talking about real life situations and distances, we're not going to use that symbol here. If you look at the case of the first problem, now you should all remember the Pythagorean theorem, and the Pythagorean theorem states that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So it's important to identify the hypotenuse, which is directly across from the right angle. It's typically written c squared equals a squared plus b squared. And we can solve for that using any two lengths of a right triangle and find the third. So in this case, they're actually looking for the hypotenuse. So x squared equals 2 radical 5 squared plus 5 squared. And if you solve that, which you should go ahead and do, you would get x squared equals 45. If I'm just solving that equation, I would say x equals the positive or negative square root of 45, which is the positive negative 3 radical 5. Now in math, one of the techniques we use is we say reject this solution because it is negative and we're just talking about distance. So the actual solution here is 3 radical 5, only the positive answer. So you have 3 more questions there. You can go ahead and solve those on your own and come back and check your answers. In number 2, I got x squared equals 8, which means x equals positive or negative 2 radical 2. I reject this, and I come up with x equals 2 radical 2. Number 3 is a 30, 60, 90 right triangle, which you will have become very familiar with next year, in which the hypotenuse is 16 radical 3. If you didn't know this, which you're not expected to, you can get this information now and then pause again and stop the video, solve it. The short leg is 1/2 of the hypotenuse, so that's 8 radical 3. So now you should be able to solve for the missing leg. I'm going to let my missing leg be x. X squared, 8 radical 3 squared, equals 16 radical 3 squared. And if you figure out all that math, x equals 24. In number 4, I got x to be 20 and y to be 16. Now we're going to look at some Pythagorean theorem word problems. I'd better see pretty pictures. I have drawn a right triangle. They may involve right triangles. They may involve rectangles. Draw the picture. Then you don't need let statements. In this case, a wire stretches from the top of a pole 9 meters high to a stake in the ground 3 meters from the foot of the pole. What I need to find is the length of the wire in simplest radical form. This is the same as writing exact. Whenever you see a word that says exact, you want simplest radical form. In this case, it's a simple Pythagorean theorem problem of x squared equals 9 squared plus 3 squared. If you solve that, you should get x equals 3 radical 10 meters. You can pause here and try the rest of these on your own. Have a great time. 2. The answer is 4 radical 5 feet. In this case, you had to set up your unknown as x squared plus 8 squared equals 12 squared. So that's actually a subtraction problem, 144 minus 64. In number 3, I got the width to be 5 radical 5, which gave me a perimeter of 20 plus 10 radical 5. And 50 radical 5 inches squared is my area. Number 4. Some of you might know that little trick about the side of the square, but if you don't, the side of the square can be found by Pythagorean theorem, and so it is 4 radical 2. That gives me a perimeter of 16 radical 2 and an area of 32 units squared, centimeters squared. In number 5, if I look at this trapezoid, you have to be careful here because this entire base is 28, which means I know this part of it, if I drop a perpendicular, that's going to make a rectangle here. Opposite sides of a rectangle are congruent. So this part of it's 12, which means each part of these little segments has to be 8. And the height is 6, which makes that a 3, 4, 5 right triangle. You can use Pythagorean theorem, but that is known as a Pythagorean triple, 3, 4, 5, and I think we talked about that a little bit last year. If you didn't remember, Pythagorean theorem is always your sure bet. So the last question, number 6, I got was C. That does not work in the Pythagorean theorem. So that's it for these. We will continue with Pythagorean theorem practice tomorrow. Have a great night, everyone.